Hi, this is Shuaiyu. I'm doing the probability in stochastics, homework 11, and of course the question asks about the stochastic process as x is WS processes, so the correlation are all in concern of tau and power spectral density with as xx omega shows that Rxx tau is a real and even. So given the real process as xt and it is a white sense stationary process, so we could write the autocorrelation functions is here. It's nothing but the expected value of t and t times xt t plus tau if x is real, and then all of the function inside the function that x and xt plus tau is not real, so the expected value is also real. So next, check on the whether it's even or odd or some sort of properties like this. The first thing we should check is about as Rxx minus tau, which is nothing but the xt times xt minus tau. We shifted these two elements by tau equally, and then we get it xt plus tau times xt, which is nothing but we change the order of two elements, and then it's equals to the autocorrelation function of R valued at tau. The second question is about to check the SXX, the power spectral density function is even and positive. For the positive parts, that the power density function S here represented, could be write that a Fourier transform of R of the autocorrelation function, which means that R here is nothing but a power of X. So R is always less greater or equal than 0, which is non-negative, and thus if the function within the integral is always be positive ones than the non-negative ones, then the function gonna be the answer non-negative. Also, we could write that because it is kind of like an even function, so we could write formally write as leave out the sign because of the even and odd function times together, they could get an odd function, and then they could just cancel it out with symmetric integrals on the integral. So here we got a much more simplified version of the Fourier transform, and which cosine is an even function. So we could write a power density function here valued at minus omega, which is also the same as the power density function valued at omega. So it's an even function. That is all about the question number 1.